Hello everyone, welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kyle.
And this week we're going to go deep into tech debt.
Alright, so let's dive in. What is tech debt?
Okay, tech debt is a term that means a professional developer makes a judgment call to go with a suboptimal decision with the obligation of repaying it in the future at some time, meaning coming back and fixing it.
Right, and as you said, it's a professional decision. It was not a reckless decision.
No.
They measured the impact of the decision and they decided to go with a suboptimal solution for now, with the promise to pay it as soon as possible.
Exactly.
So tech debt does not mean bad code or bad architecture or bad code bases.
It doesn't, no. Although it is used as a synonym perhaps these days as lousy code. Like we hear a lot, okay, there is a lot of tech debt in this code base, meaning, okay, there are untested parts, there is duplication, there is like some perhaps anti-patterns used there.
Some bugs
maybe. Yes, exactly. So lousy code. But it was not intended to be used as such. It was intended as, like good code. But basically, we need to come back and fix something in the future. That's it.
So tech debt is good code, tested code that can be improved. We may make a decision right now not to fully implement a feature, for example, but the parts we implement, we follow good practices, we test the code, and we allow it to be extended in the future.
Yes.
For example, recently I was working for a banking app, and in one of the features we had to download a list of currencies, and part of the requirement was to cache the list of currencies. But we just didn't have time to implement the caching. We had a very important deadline, so we decided not to implement the caching. So every time you go to the list, you would download it again. So we had a fully functional feature that was tested, good code that could be improved, but we didn't implement the full requirement. It was suboptimal, but could be improved. It would be easy to do. The code was clean. It was easy to understand where to put it. There was a place already prepared for it to be extended and added the cache. So we had some tech debt. We were not fully implementing the desired feature, the full spec. But we had working code, tested, good code that could be improved. So this is tech debt. There was some things left over from that feature. It was not fully implemented. And we need to go back and deal with it. We need to go back and pay the debt.
Exactly. So there you have it. A prime example of tech debt. Professional developers being aware of their actions, understanding the ramifications for the tech side and the business side.
And even the customer side, because in that case, they also got a suboptimal solution, right? Every time they go to the list, they need to fetch the same list of currencies. So they were kind of interacting with a suboptimal experience. But it worked. We could validate the product if the customers actually wanted that feature. So we gained a little bit of time, but we could go back and add it later.
Exactly.
So that's it. Tech debt is good code that can be extended, that is tested, but maybe it doesn't implement fully the specs, or it has a design that is suboptimal for what the team desires based on their standards. But it was deliver something faster, but go back there and fix it as soon as possible.
It all comes down to the risk-reward ratio we've been talking about for so many episodes. At that point in time, you knew that there is very small risk involved, but the rewards are potentially a lot higher than the risk that you're willing to get, willing to carry.
Yes.
So that's a perfect example, I think. And so the risk, the downside is very small because you know for a fact you can provide a solution that fixes that problem, but everyone remains happy. For example, the customer will have the same but even improved customer experience. The business will be able to validate what they want to validate, and the code base will be even in a cleaner state.
Yes. And we could also get faster feedback. So in that case, for example, maybe we realize that the customers never change the currency.
Right.
Or it's so unlikely for them to change the currency that maybe we shouldn't even cache it. So by getting this faster feedback, we could make more decisions. We have more data to know what the customers actually need. So sometimes you get tech debt just to get earlier feedback. And that's completely fine as well.
Exactly. There's nothing wrong with that. This is actually how things should work. By making such decisions, again, low risk, potentially big reward all the time. And if you're doing things right, then you carry very little risk.
Yes. And that's why tech debt is not bad code, because bad code carries a lot of risk.
Exactly.
It carries bugs. It prevents you from extending the code later on. It makes you afraid of changing code. So that's why tech debt means sustainable debt. Or it should mean sustainable debt.
It should mean, yes, exactly.
So good code is a prerequisite of sustainable tech debt. If you don't have good code, if you don't have tested code, you have unsustainable tech debt. And the interest of unsustainable tech debt is much higher. Every minute you don't fix unsustainable tech debt, it's going to compound, until there's a point you cannot pay off the debt anymore.
It blows up. Yep.
Exactly.
That's what happens with it. Exactly.
So you want sustainable tech debt, and only sometimes, when you want early feedback, or when you don't have time to meet a deadline. So you make a decision to not implement fully the feature, or not follow 100% the standards of the team, but it's still good code, tested code that can be improved. And bad code is just unsustainable tech debt. So you don't want ever unsustainable tech debt. Ever. There's no reason for it.
Yeah, that's it.
So next question. Tech debt sounds bad. Should I never create tech debt? Or why would we ever want to create tech debt in an iOS codebase?
Okay. So again, like we covered the good kind of tech debt, the prudent kind that allows you to go fast, allows you to validate business assumptions and implement the vision perpetually.
Yes.
Now, there is the other side as well. The lousy code that we mentioned. Should you ever create lousy code? No. You should never create lousy code.
Never.
Exactly. Yeah. But let's be realistic. In our careers, we're going to have to make compromises. You should take that as a fact. We do. And we believe that's a good strategy to take it as a fact. And there are going to be consequences for these compromises, and the consequences are going to affect the code base. Now, our mission, our goal is to constrain the consequences in the code base so it doesn't affect it negatively a lot.
Yes, but again, these compromises doesn't mean you are writing bad code, you're being reckless. No, compromise is like delivering a feature quickly to get more feedback. Maybe it's not the perfect design you wanted, but it's better to get feedback so you know the direction the product is going, so you can make better decisions for the design in the future. So maybe you wanted to abstract, but you don't even know if the customers will want the feature. So maybe it's better to just release it now, keeping the same module, keeping the same project, or release it in other apps as well. So you have this ideal you wanted to get, this decoupled modular feature. But maybe you don't need to make it modular since day one. Put it out there. So you're saving time.
Exactly. That's very important because our code can always be cleaner. Our code can always be more abstract. You can always break down things into more modules. But that's not the goal. The goal is, can your code withstand the change in requirements forever? And are you able to implement these changes with the lowest cost possible? That's the question. Thus, the goal should be just to keeping the risk low, keeping the rewards high perpetually.
Yes. So this is the essence of evolutionary design.
Exactly.
You keep your options open as much as you can, but you don't need to think about the future like 3 years from now. You just keep your options open for the next step, for the next step, for the next step. And you keep evolving the design with tests, with good code, so you can keep adding features, changing features, removing features, reusing features as needed. So that's it. So tech debt, is it bad? No, it's not bad. If you use the debt in your favor for higher gains in the future. Bad debt is reckless debt. Debt that you cannot repay.
Lousy code is bad.
So should I never create tech debt? No, you should not create lousy code. But you can use that in your benefit. Unpayable debt. So careful.
Yep.
You want it sometimes, but it should be prudent, not reckless. So next question. Why do I need to understand the concept of tech debt? Isn't that a business responsibility? I'm just a developer. Why should I care about debt, money, interest?
Right. It's an extremely important topic. Tech debt affects everyone in the business, and your code base affects everyone in the business, and you're creating this thing. You're creating tech debt, basically. So no, I think it's extremely important to understand. So you can think about tech debt like in the conventional financial term of debt.
Yes.
Right? And what is debt? Debt is the result of paying with credit or borrowing, which both practices come with the obligation of settling the transaction.
Yes.
At some point in the future.
Exactly.
So credit and borrowing allow you to operate beyond your means in the present.
Right. You are increasing your resources by borrowing.
Exactly. It means that you're going to allocate the extra whatever capital to produce something, to have something of more, basically, right?
Yes.
Yeah, and that works.
Well, sometimes it doesn't.
Well,
and you have to work harder to repay it.
Exactly.
But the idea is to have this surplus initially.
Yes.
So you can operate beyond your means.
Yes, exactly. What's for sure in all cases, the debt needs to be repaid.
Yes.
That's the idea.
Always.
Right? Yes, exactly. And this is going to happen in a predefined time in the future from the time you are paying with credit or borrowed money. Right?
Yes.
I mean, it works very similarly in code bases in software engineering, where you say, okay, I'm going to take the easy solution, the shortcut, the quick and dirty solution right now. Right now, that's important,
yes.
Right? In the present, with the obligation of coming back in the future, in a future date, to repay, right? Fix that dirty and quick solution. But it doesn't happen always. Yes. That's the problem.
It's not easy to operate with debt, right? Even in our personal lives.
No.
It's hard to use debt in your favor. It's a skill.
Yes.
You need to master it. And if you really understand the concept, you can translate it into your personal life as well, in professional life. And it's a term that you can use to communicate with business people that don't understand modularity, don't understand solid. They don't care about those things. So you need to find a common language. So understanding that is not about code bases only. It's about understanding the concept of borrowing and repaying, operating beyond your means with the promise of repaying it later.
Yes, exactly. One of the worst things that can happen in code bases when you're operating with this bad kind of debt, of tech debt, is that by using the quick and dirty solution, the code base comes to the state that it's much worse than you found it in the first place,
Yes.
right? So now, not only you just did something quick and dirty, but in the future, the code base is in such a worse state, right? And that makes everyone's job so much harder.
Yes.
So that's the bad, like the reckless debt.
Yeah, and it can translate it to real life, like credit card debt. If you buy a bunch of useless things with money you don't have, and you cannot repay it, it's going to accumulate until you cannot pay it anymore.
And as with credit cards, you have interest.
It gets worse.
It's exactly the same with tech debt.
So, yeah, you need to
exactly
learn the skill of dealing with debt.
Yes.
Of making those decisions and repaying as soon as possible.
Yes.
Using it in your favor, not recklessly.
Yes.
So do you need to understand the concept of tech debt? Yes. In my opinion, yes. You should. Because it translates to other things in life, and it's a language that you can use with business people. It's an important concept.
Exactly. And everyone will most probably appreciate that. And if they appreciate, then it means they have a higher opinion of you. They can trust you more easily. You can assume more responsibilities in the operation. And that's a good thing. That leads to remarkable careers.
Yes. A common language is going to help you gain influence in the team and trust. So, next question. What are some side effects of unsustainable tech debt in iOS teams? Well, first, let's clarify again that tech debt doesn't mean it's unsustainable. There is unsustainable tech debt. That means like bad code, bad practices. They accumulated over time and it's hard to repay now. And there is the good tech debt. Prudent decisions to gain something in the short term without affecting the long term. So it's good code, tested code, they allow you to go faster, and it allows extensibility in the future. It's easy to deal with. It can be improved. So if that's it, what are some side effects of unsustainable tech debt in iOS teams? So the bad debt, the unsustainable one.
Right. I mean, like, you need, again, these signals that we've been talking about. You can observe the pattern before you see the side effects. And the pattern is always the same. You're trading disciplined actions for shortcuts in your everyday development operations.
So when you use that, you are trading your standards, right? The things you wanted to do to something suboptimal of lower standard for an immediate goal.
Yes, exactly. Which most probably it's quick and dirty as well. Right.
Hopefully not.
But what are the side effects? What this trade of disciplined actions for quick and dirty will yield over time? Well, I believe we have a list of these things, right?
Yes. That's it. Like unsustainable decisions over time will accumulate. And this is what happens. These are the signals you should look for. Delays in release over time. Let's say at some point you were releasing every 2 weeks. Now it takes a month. And you project that it's going to take 2 months in the future. There's something bad there. It's unsustainable. It's getting worse. Your code base should get better over time. Every decision should make the code base better. So, if it's taking longer to release, the release cycles are increasing, it's because things are getting in the way. And it's most probably reckless tech debt, the unsustainable kind.
And the irony here is that the idea of tech debt is that in the beginning, you should be releasing faster, right?
Yes.
But if you pass this threshold that you don't repay the debt, then you're going to start releasing slower and slower and slower.
Yes. Another side effect. Increasing defects, bugs, mistakes. Because the code is a mess. If you have unsustainable tech debt, you don't have tests. You have bad code, bad architecture. Why? The quick and dirty solutions, as you said.
You don't know what's going on.
And it accumulates, and the bugs start to appear. And more if statements are added to fix the bugs, which introduced other bugs.
Exactly.
And so on. So this is what happens. Also, code freezes. Because when you start getting all those bugs in the code base, at some point, they have to stop development. We don't write any feature. Now it's just about fixing the code base and putting it in a stable state. And it's hard to get out of there. It's hard to fix a code base that is lousy, it's messy.
It also hurts the product and the business because the product development freezes, right? It stops, right? So that's like a terrible situation a business can find its tech team in.
For the customer as well. They don't get the features they want, what they are paying for. And also the developers, they lose trust with the business. So then they start being micromanaged.
Yes.
And it's hard to build that trust again once you lose it. You can. You're going to have to work hard. Other side effects of unsustainable code bases: conflicts. Either merge conflicts in code and conflicts in the team. Interpersonal conflict of someone trying to fix the code base while others are just going around and making a mess. And everyone gets in each other's way. There's no clear modularity in there. You make a change in the login module and you break the checkout.
Exactly.
And then you start pointing fingers. Someone say, well, I did the checkout, but Bob broke it because he changed the login module.
It's not my fault.
Yes.
And that's how you can see a team coming apart, right? When there is this assignment of blame, there is no one wants to be responsible because how can they? Like that's exactly
Yes.
right. In the example, someone else is responsible for your problem. So it's very hard to deal with this.
Yeah. It's not a nice problem to have.
No.
Other bad side effects of unsustainable debt: increasing rework, or even like full rewrites of a feature or the whole application.
That's the blow up metaphor of technical debt.
Yes.
There is nothing you can do anymore. It has become such a liability that pouring more resources in the current version is just the equivalent of lighting money up, burning money. And what can the business do? Well, they're going to start over. They're going to have to rewrite the whole application. And that's extremely costly most of the time.
Yeah.
And it's just, it's not productive. That's the hard facts. It doesn't help productivity.
I would say that a full rewrite is the equivalent of bankruptcy.
That's it.
You need to reset, default.
Default, yes. Yes, exactly.
You reach such an unsustainable case that there's no solution. You need to start from scratch.
Yes.
Reset. That's very expensive for everyone. No one wins.
Yeah.
No one wins from that.
Don't want to be there.
There's no winners.
Nope.
Other side effect: low team morale. Again, no one wants to be in that situation. Just don't want to go to work. Wake up in the morning and you're like, oh, I don't want to go to work and deal with that code base.
Exactly. And what's going to happen? What's the side effect of that? People will leave, right?
Yes.
We're going to see a low retention in the business. The business cannot keep its key players, the key developers in the team, because people are unhappy. Like, why would they want to work in a place like this, with a code base like this, with conflicts all the time, assigning blame and responsibilities left and right? It's terrible.
Yeah, so everyone that has a way out will take it.
Of course. And in a hot market like this, everyone has a way out. That's the other side effect going on here.
But the problem is, like, even though you can find a new job, it's not a nice experience to go through this. No one wants that.
Exactly. It's terrible.
Like, this is not a desirable
Yes.
thing.
Yes.
Just don't want to be there. You want to prevent this situation. And if you can prevent the situation, every business needs those skills. Every business needs people that has the skills to prevent the situations. And they are willing to pay a lot for leaders, for developers that can lead a team to create sustainable and good products. And that's a valuable skill that is scarce. If you build it in this hot market, you're set.
These are the roles and the opportunities we mentioned in the previous salary episode for the top 1%, for the top 5, 10%. You know, like these developers that have the 30%, 50%, 100%, 200% increase from the average.
Mm-hmm.
They are remarkable developers that can lead and take responsibility and just make a better place the team and the code base, right? That's it.
They create teams that everyone want to stay.
Yes.
Where everyone is learning, is sharing,
yes,
is teaching. So you should build those skills if you want a remarkable career.
Yes.
So that's it. Those are some of the side effects of a lousy or unsustainable code base with loads of unsustainable tech debt. And you need to build the skills to prevent that. Those are valuable skills that will give you an edge in the market. Because no business wants tech debt or unsustainable tech debt.
The reckless kind.
So next question. Can refactoring help with tech debt?
Okay, so let us clarify first what refactoring is. And I have here a passage from the Clean Agile book by Robert C. Martin. And Robert C. Martin states that refactoring is the practice of improving the structure of the code without altering the behavior as defined by the tests. In other words, we make changes to the names, the classes, the functions, and the expressions without breaking any of the tests. We improve the structure of the system without affecting the behavior.
So that's it. When you are refactoring, you're not adding feature, you're not changing features. You're simply changing the structure, and the tests are passing in every step. You don't change behavior when you refactor.
No, and the behavior is defined by the tests, Robert C. Martin states here, right? That's very important because we hear many times cases where developers and teams say, well, before starting this feature, we need to refactor some of the code. But there are no tests to back up the refactoring. What they mean is basically rewriting parts of the code base. And that's very important here because this now is subject to reckless technical debt.
Yes. And regressions.
And of course, like everything that comes, all the side effects that we mentioned before, right? Because you don't know if you're going to alter the state of the system that perhaps is going to generate some problems for the app.
Mm-hmm.
So how can you check that?
Yes. Without tests, you're not refactoring. You are rewriting and hoping that everything still works.
Hoping. Exactly.
So, can refactoring help tech debt? Yes, if you're actually doing refactoring. If you are just changing the structure to improve the code, and you have tests guaranteeing that you keep the same behavior throughout the refactoring. So when you use refactoring to pay the debt you created previously, yes, it will help you deal with tech debt. But you need to have a good design and tests to be able to refactor code. Because again, good code and tested code is a prerequisite of sustainable tech debt.
Okay, and I have another quote here that it's going to shed some light on refactoring. It's going to make you understand even better. Again, from the same book, Clean Agile by Robert C. Martin. Refactoring is a continuous process and not one that is performed on a scheduled basis. We don't make a huge mess for days and days and then try to clean it up. Rather, we make a very small mess over a period of a minute or two, and then we clean up that small mess. The word refactoring should never appear on a schedule. Refactoring is not the kind of activity that appears on a plan. We do not reserve time for refactoring. Refactoring is simply part of our minute-by-minute, hour-by-hour approach to writing software.
There you go. You should be improving the design as you go. So maybe you didn't fully implement a feature, you left some tech debt before, but you have clean code, you have tested code, so when you go back there in the future to finish the implementation, you keep refactoring the code with the test passing, and that's it.
And even better, make it part of your daily operations, such as in test-driven development. It's part of the methodology. It's red, green, refactor are the steps. Refactor is baked in the process.
Yes. You don't need to schedule it.
Nope.
Oh, before we start this feature, we need to have a week to refactor the code. No, you don't do that. It's part of the process.
Yes.
You do as you go. You don't need to stop, have a code freeze to refactor. That's not refactoring. That's rewriting, most probably.
Yes.
So yes, you can use refactoring to help you with tech debt. But remember, good code and tested code is a must to create sustainable tech debt. And it's a must to be able to perform refactorings. So next question. How can I prevent tech debt? I think they mean, how can I prevent unsustainable tech debt?
Yeah. So how can I prevent creating lousy code?
Yes, creating a mess.
One word, discipline.
Yes.
We've been talking about a bunch of principles in this podcast. Just follow them.
Yes, discipline. But sometimes you have the discipline, but you don't have the skills. Then you need to practice, learn the skills. So you need both the skills and discipline.
Exactly.
So maybe you need training to get the skills first. Maybe you get this from the business. Maybe you have seniors that can help you. You have mentors. That's it. Otherwise, you're going to have to find help. Maybe pay for a course. Read some books. Practice on your own time. Then when you have the skills, you need to use them consistently. Discipline.
Exactly. Because again, like all these processes, test-driven development, the solid principles, creating a modular design, like even going and, studying actual monetary credit and debt and their cycles, all these things can be extremely beneficial. But I think you said it best. You need to apply these things. You need to study them and then apply. And like with every opportunity that you find.
Consistently.
Exactly. Be relentless.
So for example, as you said, TDD. Write your test first. If you want to have testable and a good tested code base, you write the test first. That's the discipline. You have the 3 steps. You write the test first, see a failing test, then you make the test pass, and you refactor. And you keep doing this every minute. At the end, you're going to have clean code that is easily refactored. If you want tested code, you write the test first. That's the discipline that you need to follow. It's much faster to write the test first because the test is going to be influencing your design. You cannot write untestable code if you write the test first. It's just impossible.
Why make it a possibility? Just take the option out of the list.
Yes.
If you write the test first, well, you always have the test there. You don't have to remember or schedule or make a fantastic excuse for not writing it ever.
And sometimes you don't know how to write the test first. You're dealing with something you've never done before. Then you spike some ideas first until you are familiar with the problem you're dealing with. Then you discard that branch, you go back and you write the test first. And that's it. And if you don't have the skills to test first, you need to get some training. Ask your boss, ask your team lead to invest in you. Otherwise, you're going to have to invest in yourself. And then you practice and you are consistent. And you're going to get good at it. and fast at it as well. Because if you think you're going to go slower by writing the test first, for example, yes, if you're not good at it, yes, it's going to take longer. But then you get good at it by practicing, and you're going to be fast. And even faster than you were before.
That's it.
That's it. Consistency. How can I prevent tech debt? With skills, discipline, and consistency. That's it. So get into unit testing, TDD, learn the solid principles, learn how to create modular code bases, so learn modular design, and learn, practice, and execute continuously. The learning journey never ends.
That's right.
So next question. What is the worst that can happen with tech debt in iOS teams?
Well,
the worst?
I mean, yeah.
Well, bad things can happen, but the worst, I don't know. I've seen teams like accumulating so much tech debt they couldn't move anymore and they have to rebuild the product. And I've also seen teams that needed to rebuild the product. They didn't have the budget. They have to just simply discard the product.
Yes.
Throw it away. And the team was fired. For me, that's probably the worst case that can happen. Like, they don't have money to keep themselves in the game.
That's for the developer and business side, but there's also the customer side.
Yes.
So the worst is, I don't know, like bad customer experience.
Yeah. Paying for a product that is suboptimal, doesn't deliver what you want.
Yes. It can be even tragic, let's say, in some cases.
Yes. We are paying for a software right now that we use in our day-to-day to edit the videos.
Right.
And it keeps crashing on us.
Right.
And we are paying a substantial amount to use that software.
Right. Right.
And it keeps crashing. It's a terrible, terrible solution they provided. And they cannot fix it. They keep patching it, but it still crashes. It's still slow. They're trying. But it's probably a very messy, unsustainable code base they have there.
Yes. So I think it's safe to say that the worst is like bad things for everyone. Now, how are they going to materialize these bad things? You know, for the developers, what's the worst that can happen? Is it like, if you think about it, to lose your job? Then sure, it can happen for sure. If the tech debt blows up, then the blame usually falls in the dev team. For the business, I don't know, the business doesn't get funding, declares bankruptcy.
Yes.
Right. But for the customers,
losing money.
Sure. Losing money. Yes.
Losing opportunities, losing whatever they were using the software for.
Exactly. And that can be extremely bad in some cases.
So that's it. A lot of bad things can happen. So what are some examples of tech debt on iOS and Swift?
Okay. We have the usual suspects and the anti-patterns.
Massive classes with thousands and thousands of lines of code and responsibilities and conditionals, if statements everywhere, chained.
Yes, exactly. That's the MVC, where M means massive, right? A massive view controller. Where basically you have classes, like whatever, view controllers, view models, doesn't matter, that they do a bunch of things. They have so many responsibilities, like view life cycles and view state management.
Networking.
Persistence, navigation, like coordination, all these things.
Dependency injection. Dependency location.
All these things, yes, exactly. And basically you can't work there. Like, there's a threshold that once you reach that, it blows up. You can't go there and make a change. You can patch things up to a point.
Yes.
So, yeah, this is a clear sign. If you're seeing this, then be prepared. Bad things ahead.
So, untested components with thousands of lines of code. Number one, probably.
Yeah, hands down.
Number two, global mutable state.
Yes.
Just accessing global state and mutating it everywhere. Put threading in the middle, and you have a recipe for bugs and unmaintainable code bases.
Yeah, madness.
Next, not handling errors accordingly. You have a try catch and you just say try bang.
Yep. Yep. Okay. So yeah, exactly.
For some wrapping optionals. And just not dealing with the set paths.
Yes.
Well, we're never going to fail.
Right.
Until it does.
Sure.
The same for unknown references, you know?
Yes.
Even inside closures, when you get like unknown self, yeah, I don't need to unwrap it. Yeah, it's convenient until you have a crash.
That's the problem with the unknown and the previous, the try bang that you mentioned before, is that you're making it possible for a runtime crash there.
Yes.
Well, you could just easily eliminate this option, this path, like this physical path, literally, right? By just handling it or just wikifying and just putting self ?
Or if you say it would never, ever, ever, ever be nil, let's say, and you say, because it would never, ever, ever be nil, I'm going to use unknown, you have a bad design. Because your design allows it to be nil, but you're saying it will never be nil.
Right.
So you better improve your design so this state is unrepresentable.
Yes.
You should not even compile if you represent a state that should never, ever, ever happen.
Yes.
So fix your design or wikify it. That's it. Next, files and components with hundreds or thousands of lines of code. Even like configuration files, sometimes not even code, but you have like an XML that configures your application. And it's a mess.
Yes.
Thousands and thousands of lines of configuration code. I don't know, maybe a storyboard? Massive storyboards.
Yep.
And there are multiple people changing that XML at the same time. Recipe for disaster.
Yep.
So next, protocols with loads of methods.
Right.
They probably also introduce some leaky implementation details into the protocol. If you create a protocol that should hide core data from a higher level module, but you are passing parameters to the protocol methods that have references core data types, like NS managed model or NS managed object. Well, you're breaking the abstraction, there are implementation details there, and probably adding loads and loads of methods that only a few clients need. So you're violating the interface segregation principle, the single responsibility principle, the open-close principle.
Just all of them at some point. It's bound to happen.
And it's going to break modularity. If you leak implementation details in protocols, you're breaking modularity. You're coupling the modules, even though you're using a protocol in between. So you're not getting the benefits of the protocols, but getting the downsides of the protocol.
Exactly. Yes.
Next, not inverting dependencies on third-party frameworks or any infrastructure framework like Core Data, Realm, Alamo-Fire, and RX Swift. Those frameworks that tend to be referenced in every module of the application.
Yeah. You're creating this tight coupling with these libraries. The creators of the libraries love it because you're using your product.
You're hooked.
Exactly. You're hooked. You can't untie this collaboration between your code and their code. But ultimately, this is problematic for your design. You want to have an abstraction in between. You want to invert the dependency. You want the third-party code to depend on your code, not the other way around. It's going to save you over time. Just, like the risk for blowing up from this kind of thing, with tech debt it goes away, basically.
Yes.
So you want that.
Because I get a bunch of objections against this, saying that, no, I'm using core data, I'm never going to change it. Or I'm using Alamo-Fire and I don't want to ever change it. But we get emails weekly of people saying, I want to migrate my code base, but my previous coworker added all those CocoaPods dependencies, and I cannot update my project to Swift 5 because it depends on some old versions of Swift. And if I migrate, even though there is the binary compatibility, it crashes at runtime. Horror stories every week, always the same. So If you think it's not going to happen, it will happen.
Yes.
It happens every day with teams everywhere.
Yes.
So invert the dependencies. You can use the frameworks, but invert the dependencies. If the framework hurts you somehow, you replace it with something else. And you can also test things in isolation. You can develop things in isolation.
So much easier.
Which brings the next problem, not using dependency injection properly. Just accessing those frameworks, especially the ones that give you singleton instances, like alamofire.shared, URL session.shared, or you go and create your own core data.shared.
Yes.
Instead, you should use other dependency injection strategies, like injecting the dependencies explicitly. So you have much more freedom to compose this object with different instances, to test things in isolation, and it's going to be easier to maintain the code base in the short and long term. So don't use ambient context, service locators, or any other global way of accessing dependencies. Those are anti-patterns. And why are they anti-patterns? Because they are better solutions. If there were no other solutions, they would be the solution. But they are considered anti-patterns now because they are better solutions. Proper dependency injection, constructor injection, method injection, property injection from the composition root.
That's it. It's another one now because, like we see many times, there is no composition root. So if you don't have a composition root and you start instantiating components inside other components, then you run this risk up of creating technical debt there, right? Because the component that you're instantiating perhaps needs a dependency or two.
Yes.
Where it's going to find a dependency. You're either going to pass it in the component that instantiates it, right? So now you are having this two-level kind of dependency there. Or like if it's a singleton, you're going to have to just pass it indirectly. And that's not good either.
It's going to increase coupling and prevent you from achieving easy polymorphism, achieving polymorphic behavior, allowing composability. So avoid global dependencies. Also, another problem with unsustainable tech debt is slow build and test times. It takes an hour to fully test your application in the integration pipeline. Every tiny change will require 1 hour at least to integrate with the current master branch.
Yes. And that's the problem when one single change that you want to make in the code base affects multiple parts, right?
Yes.
You need to recompile, redeploy everything, and you run the risk of breaking things. And you run the risk of waiting a bunch of time for things to recompile. Why? Like, this should not be happening. You can constrain that.
Yes. So, bad code, bad architecture, or unsustainable tech debt will make everything coupled. So you cannot decompose your application. So the build times increase over time. The test times will increase over time as well. You cannot test things in isolation, build things in isolation, integrate modules in isolation as well.
Yes.
This is going to become a bottleneck. It's just going to increase over time. So next, any kind of nested conditionals or even like closure callbacks. You know, the arrow code. There you see it looks like an arrow. If, and then closing the if statement.
Yes, exactly. That's chaos.
Yes. You want to avoid that. So if you have like 3 levels of if statements, let's say 3 Boolean checks there. You need at least 8 tests?
Yes.
At least?
At least. Yes.
And if you have 4 chained if statements, you need what? 16?
Yes.
And it grows exponentially.
Yes. Exactly. And imagine
you don't want that.
an if statement having like an and or an or in the condition there. Just like boom, it blows up.
What about greater than or equal?
Right.
That's 3 tests you need to triangulate all the scenarios. So you do need conditional statements, but they should be contained in higher level components that make decisions. Down the chain, you just have objects or components communicating and sending messages to each other.
Exactly. Flatten.
Conditionals should be in high-level components, policies, and rules that make decisions. Otherwise, you're going to have an explosion of conditionals, and it's going to be very hard to test your application. Other problems. A large number of dependencies, like a CocoaPod with 20 third-party dependencies. So yesterday, a friend asked me to help him with a project. The freelancer disappeared. The project is not running. They asked me to fetch the codebase from the remote GitHub. I do it. I open the CocoaPod, and there is 21 dependencies in there. And of course, 1 or 2 are not compiling. You cannot migrate to Xcode 11. It's a nightmare.
Yeah.
It's just a nightmare. I'm going to waste probably 2 days dealing with this.
Yeah.
Because of unnecessary craft.
Yeah. There goes the productivity.
Yes. Nightmare. And that's going to be my week. Next. Not breaking down tasks properly. When you have tasks assigned to you, sometimes you need to break it down into more tasks.
Right.
If it's a massive task, you cannot even estimate it.
Right.
So you need to break down tasks into smaller tasks, maybe make a checklist, and then you can even distribute the tasks to other developers in the team.
Yes.
Otherwise, you're going to have these massive tasks. You're going to create a branch that's going to be there for weeks and weeks. It's not going to integrate often with the master branch, with the trunk. So other developers are pushing code and start getting conflicts all the time.
Exactly.
Break down the tasks, integrate often, and have smaller commits as well. Let's say commit every 5 minutes or less. Every time you make a tiny change, you commit. And once you have a set of commits that is stable, you push. Create a merge request. Merge, integrate often. Now, if you create a pull request with 100 commit, 207 files changed, good luck getting someone to review that fast.
But
if you create merge requests with 6 commits, 4 files changed, it's much more likely someone's going to have a look at it quickly, and you're going to integrate this code much faster as well.
So that's it. Like a simple example in what you're saying is, imagine you have a card, a ticket that says implement tracking, right? So now you just have to implement tracking for a whole application. This card is too big to be just in a single ticket, right? It needs to be broken down. What kind of tracking are you going to use? So the infrastructure details, what places, what events would you like to track? What page views, perhaps?
Mm-hmm.
So this is like, imagine how many checklists, if you break up this card, you can create there.
Yeah, maybe you should even spike some different vendors to see which framework you're going to go with.
Exactly, right? And now that's the project management side. How does this translate to the development side? Well, each item in the checklist, maybe can be its own pull request, for example. That means like a bunch of items in the checklist can have many commits. Git scales insanely well, so that's not a problem. If you're worried about the number of commits, that's not a problem. It is solved.
It's desire.
Exactly.
It's desire to have a lot of commits.
Yes.
So yeah, don't be afraid of committing often and integrating often as well. It's going to be better for everyone in the team.
Yes.
So next question. How long until tech debt starts impacting negatively my iOS app or the iOS team? How long? Depends how bad it is. But it could take like hours. Sometimes a bad decision you make now is going to block your peers that are working on another feature. It can take minutes. It doesn't take that long. Bad decisions will accumulate in the long term. It's going to be unsustainable. But their effect could be immediate. You could introduce a bug, for example. It's an immediate impact of bad, unsustainable tech debt.
Yes.
Of taking shortcuts, the quick and dirty way.
Yeah, I think that's it. I think you said it best.
Nothing else to add. Next, I work in a legacy iOS project full of tech debt. How can I improve the situation? Well, that's the reality, right? A lot of people inherit those code bases. Maybe they didn't even create it. They just join a team and they inherit this terrible code base. And now it's their problem. They need to deal with it. Well, if you care about these professional disciplines, about clean code, about writing tests and creating good solutions, sustainable solutions, and the team you joined don't care about those things, that's going to be hard. That's going to be a hard problem to solve. They just don't care.
Hard is, you're putting it nicely there. It's going to be a nightmare.
Yes.
There's going to be conflict all the time. Just conflict of interest. Like you want something disciplined, sustainable, clean.
Yes.
Other people don't want that. Well, what do you think is going to happen?
Yes.
So yeah, maybe it's not even worth it. Maybe it's worth considering joining another team that they have different standards. They have a different code base.
If you don't want to go the extra mile to maybe try influence change in there, if you think it's a lost cause, find a new team. Now, if it's a team that they got to that point, but they had good intentions, they just don't know how to make things better. They're trying their best and they are open-minded. Then you can influence change.
Yes.
You can bring the skills in, you can train everyone. You can start a training program in there. How valuable would this be for the business? You can get buy-in from everyone. You can go to your manager and say, hey, I practiced this over the years and I can influence change here. I can help the team get better and solve those problems. And it's going to take time because it takes time for people to learn, to start practicing, trusting the process. Maybe the productivity is even going down in the beginning.
Yes.
As you're learning something new, productivity will probably go down. That's fine. Set the right expectations to everyone, to the business, to your manager, to the team. We're going to do something different. It's going to take time. We're going to practice. But in the long term, it's going to pay off.
Yes.
They are open-minded and they are willing to do what it takes. Then you have a chance of fixing the problem. And it's going to take time. Be patient and help the team stay on the path. Be disciplined. Give them the space. When they are stuck, you help them. That's how you can influence change.
And this is a case where the incentives are aligned between the business and the dev team, but everyone should be aware the time required, the patience required, right? Exactly, because setting the right expectations is key. Because
yes,
in the beginning, productivity is going to drop, right? So you're betting, right? So you have like this asynchrony going on that in the future, we're going to see better results. Well,
yes.
if you don't have a high level of conviction there, both from the developer side and the business side, you can very easily lose touch and lose faith on what you're doing and say, well, this doesn't work. That's not the way to go. Let's go back to just patching, and having this legacy code base.
Because the question is, I work in a legacy iOS project full of tech debt, right? It's a terrible code base, let's say.
Yeah.
If you have a terrible code base in your hands, yeah, it's going to take time. It's going to take time. I don't recommend a full rewrite. That's like worst case scenario. Avoid it. But improve things as you go. As you go. There's a new feature. There's a bug fix. You make the code base a little bit better around that piece of code changed. Every time you change the code base, you make it better. Little by little. You don't need to stop the development of the code base. You don't need code freezes. You don't need to put refactoring on the schedule. Every time you change a little bit of code, you make the code base better. So you're going to get buy-in from the business because they don't need to stop the features. But every tiny change you make makes the code base better. Every change makes the code base better. It's going to take time, but at some point, you're going to have cleaned everything. Maybe it's going to take a year, 2 years. Doesn't matter. You're there for the long term. That's what it takes.
That's it.
patience, and consistency.
Yes.
Next question. The product team doesn't care about standards, like clean code and unit testing. It cares only about deadlines. What should I do? Okay, so this is a person that wants to do a good job.
Yeah.
They want to test, they want to write clean code, but apparently the product team doesn't give them space to apply the good professional software disciplines. So that's a big problem.
Yes, it is.
Because ideally, the product team should not dictate how the developers work.
No.
The developers have the technical expertise to make those decisions.
Exactly.
If they're micromanaging you and saying, don't test, don't follow solid, don't create modular code bases, like, how can they make this decision if they don't have the technical expertise?
Yes. I can only think very, very few examples that this kind of behavior can work well. It can, I think it's extremely unlikely to work well for businesses that are backed by a, like a tech product, a code base, basically.
Mm-hmm.
Because, sure, short term, maybe can work, maybe can yield the results, the product team expects. Maybe you ship a version of the app and that's it. Well, what's going to happen in a year? What's going to happen in 2 years? One thing is for sure, like the code base is not going to withstand bad practices. It's going to blow up. So
yes.
What's good there?
Maybe the business doesn't care about the long term. They are not there for the long term.
That's one of the cases I was thinking about.
Yeah. The problem is, if you care about the long term, you should not be in a business that doesn't.
Yes.
You should not be working in a team that doesn't. They're there just for the short term. Create an app, 2 months later, throw it away.
Yes.
If that's not the place you want to work, you need to find a better team.
Yes.
The problem is that sometimes companies are there for the long term, but they cannot deal with their own anxiety. The product team wants things to go faster, and they push that anxiety to the developers.
And that's something considerable, by the way, because this anxiety, it is true and it is valid when there are deadlines, especially for startup businesses that have these funding rounds and the time to market and all. I mean, this is no joke. Like, it's very, very stressful to be in a situation like this for everyone. So everything needs to work perfectly in harmony, right? Like collaborate. Everyone needs to collaborate perfectly.
Yes, but that's impossible.
That's exactly right. So you need these compromises every now and then, but you also need to have prudent compromises, right? Not because there is a deadline coming and there is this perception of maybe clean code and TDD take more time. Just scratch that. Let's go, with the quickest and dirtiest solution as possible. Because maybe, I don't know, some company in the 80s did that and now they're like gazillionaires, everyone. No, I don't think that's a good bet,
So that's it. Like, if you're working in a company that really needs to go fast, it's a startup, and you like that culture, you like to be part of that rush, that's fine. You can do it, but you can create sustainable debt that you can repay. So you're creating good code, clean code, you're testing your code, but you're going fast. You're not maybe implementing the full feature as you wanted, but you can go back there in the future and fix it. You have clean code, tested code, code that works, that delivers a good experience to the customers, and you keep improving it. And if you're happy with that, that's fine. I think the problem is being in a place with misaligned goals. The company just want to go fast, don't care about the long term, and the developers care about the long term. There'll be conflicts. They just have different goals. You need to align the goals with the business. If you don't like their goals, you need to find another place to be.
That's it.
So that's it. There's nothing wrong with going fast and sometimes taking some shortcuts. If you're disciplined about it and you're making professional decisions, the problem is reckless decisions. Unsustainable tech debt that cannot be repaid.
Same as in the monetary sense of debt and in our real, lives, our personal lives. You accumulate too much, you have fun, it blows up.
Yes. So you need to learn how to deal with that, because you need to understand you are borrowing and you need to repay it. So you should only create sustainable tech debt. The tech debt that gives you a short-term gain without taking away from the long term. And this is a skill that you need to build.
If you understand that you're borrowing against your future self, then you understand the incentive also that you don't want to be in this bad position. So
Yes.
You're incentivized to pay your debt as quickly as possible. And that's it, basically.
So that's it. Long episode about tech debt, but this is an important topic.
Yes, very important.
Hopefully now you have a different view of this subject and it can help you in your professional career.
Hopefully in your personal lives as well.
Yes. Understanding that is crucial to operate in society.
Okay?
So that's it.
That's going to do it for this edition of the iOS Lead Essentials podcast. We'll see you again next time. Bye, y'all.
See ya.